we're discussing tonight is retrieval-augmented generation, which is a technique for adding information to large language models. And so we've got a few things to talk about today. We're going to cover some of the basics. I'm going to demonstrate a way that you can do retrieval-augmented generation without writing any code, and we'll look at that. And then we'll look at an experiment that I did with this technique and how I tried to extend it and add some value to it. So that's kind of our plan for today. So let's start by talking about large language models. The illustration that you see on the screen there is the transformer architecture, and this is the key piece of technology that was developed in 2017, and when added to traditional neural networks, the transformer enables some pretty incredible capabilities. So the LLM is able to process. So go ahead.
Projector out of focus, or is the
maybe it's a little out of focus. Not sure. Well, that's worse. That's worse. There we go. It looks exactly the same to people, the people on the video or online, I would imagine. Oh, and there's Goran. Welcome, Goran, too. Great. So the basic capability of an LLM is being able to consume a set of tokens, a set of word segments, and predict the next one. And that is essentially the foundational technique and that's what folks were going for when they initially developed the transformer architecture. It was developed for machine translation reasons. Those were the kind of tools that were being built. But what happens when you scale these things is that they begin to develop new capabilities that just emerge from both the training data that is applied to them, as well as the sheer scale of the model itself. So if you're interested in exploring LLMs, and this is not meant to be any kind of an expert introduction, I'm trying to orient everybody. I am not an expert on this stuff. I am a user of LLMs, certainly not a researcher or anything like that. But if you're interested in large language models and learning about them, you have a lot of open and commercial options that you can explore. I've listed some of the companies that make leading large language models today. When you use these things, you get some pretty incredible capabilities. You get the ability to summarize, to synthesize two disparate pieces of information into something new. You gain the judgment and reasoning abilities. There are a lot of capabilities that emerge from these models. So you can access them through a commercial interface. Most of the people who are here, I would assume, have at least taken a look at ChatGPT or Mistral or DeepSeek, tools like that you can either access through a mobile device or a web browser. That's the easiest way to get access to LLMs, and you can use these techniques, retrieval-augmented generation, even with online chatbots. That's very possible. You can also use cloud providers of LLMs. Nebius is the one I use. OpenRouter is another popular one. There are many more. You can pay $20 or even $200 a month for a product like ChatGPT, and it really is a compelling product. It has a lot of features. But you can also go a more DIY route with that stuff. And, I checked my last 30 days of billing through my cloud API provider, Nebius, and I'm spending about $1.50 a month for access to, and pretty high frequency access to LLMs through that API. So you definitely can access it more cheaply. you will have to do a bit more work. And then finally, if you have the hardware for it, you can use a local LLM and products like Olama, LM Studio will allow you to run models locally. And Open Web UI is a tool that you can use to have a chat interface that will look very familiar to you. You can see a screenshot, and we'll be looking at a little bit later. You can see a screenshot of my own Open Web UI there on the slide. If you are interested in working along with us and you want to try running a model locally, you can install Docker, go to the Open Web UI GitHub page, and look for the correct Docker one-liner for your configuration, okay? If you have an NVIDIA GPU, you'll want to use one of the versions of Open Web UI that supports NVIDIA GPUs. And if you don't already have a server to provide those models to your Open Web UI, you should choose to install the version that includes Olama. So you can get basically one Docker command will give you a bundle of everything you need to get started. So you can go ahead and do that, but of course, you can also use any of the other tools that you see here to interact with data the way that we will do it tonight. Okay. All right. So there's a few ways that a large language model can be provided with information that it can then share with users, synthesize, and do all the good things that it does. The first and most expensive way is in the pre-training process. So we talked about a little bit very briefly and sketchily about the architecture of LLMs, their neural networks, and they represent data, word data and other data, numerically as vectors, okay, as multidimensional vectors. And pre-training is the process of feeding immense quantities of data through your LLM to give it some structure, okay? So when you do that, when you train an LLM, the first layer, and if you want to go back if we want to go back to this slide, the embedding layer, and we are going to talk quite a bit about embedding today. What that layer does is it vectorizes the data that you give it. So what that means is that it takes whatever textual data or other format binary data, whatever data that you present, it takes that data and converts it token by token. A token is a segment of a word, usually 4 or 5 characters. Token by token, that data is processed, okay, and converted into numeric form. And what happens is the embedding layer is only responsible for converting words into numbers. That's all it does. But it does take feedback from the subsequent layers of the large language model, which are doing different operations on that data and identifying its location in conceptual space. So if you want to think about the n-dimensional sort of representation of words in a large language model, what you'll find is that the numbers that make up that token's representation cluster semantically. So what that means is that the word cat and the word tiger will be close, okay? Their vector representations will be close together. They will be similar numbers because a cat and a tiger are similar conceptually, okay? That's really important to understand, okay? So as the model is trained, the representation of text data, semantic representation of text data is improved, okay? And then it's not purely the dictionary meaning of words. That's not the only thing. Context, the sort of grammatical rules, social rules, all the things that make up human thought as expressed by a language end up being represented numerically in the model. So anyway, that's the process of pre-training. It takes a long time. It costs a lot of money. We're talking millions and millions of dollars. Unless you are one of those companies identified on the first slide, an OpenAI and Apple or a Microsoft, you're probably not going to be doing a whole lot of pre-training. So how can we get a model to have new information if pre-training is out of reach? Well, one option is fine-tuning, and there's a few different ways that you can fine-tune a model, but essentially the process is providing more training data to a model, okay? And this is also costly and time-consuming, a fraction of the cost and time of doing pre-training. And what you are doing here is you are providing new data to the model itself. So you can improve performance with fine-tuning. You can take a model that is produced as a general purpose model, and you could, for example, train it with many examples of medical charts, and you would end up with, potentially, I'm simplifying, but you could end up with a model that has more expertise on medical matters. Okay, so we see fine-tunes available for scientific applications. There are fine-tunes out there that take a generic, off-the-shelf LLM and turn it into something that is more creative, that is more useful for things like role-playing and taking on characters. All kinds of different things are possible with fine-tuning. It's a pretty technical process. And for most of us, it's going to be out of reach unless the return on investment is very large. Retrieval-augmented generation does not change the weights. It doesn't change the representation of data in the model itself. What it does is it provides context. It provides context to the model at the time that it's processing your prompt, your query. So that contextual data is added to your prompt as though you had typed it all in, okay? And so that means that retrieval augmented generation is good for some things and it's less good for others. You wouldn't use RAG if you wanted to make the model smarter for a particular task. That's not how it works. You would use RAG if you want to make sure that the factual information that the model is giving you is accurate, okay? If that's important to you, if having access to facts, specific facts, is going to give you the performance you want out of the LLM, then retrieval augmented generation is what you want. So this is particularly useful for specific use cases. I can tell you how I use retrieval augmented generation. I am, besides being a software developer, I'm also a consultant on the software development side. I often use RAG techniques to provide context when I'm using the LLM to help me with coding. So you will find many projects and solutions out there for taking a source code repository and stripping it down, removing a bunch of things that are not going to be particularly useful, and preparing it so that it can be provided to your model as useful context. That's one way that you can use retrieval augmented generation in software development. In consulting, and Alex asks, is RAG used in the Cursor AI editor? I've never used Cursor AI, so I don't know. If someone on the call knows the answer, please jump in and fill in that answer. So in my consulting work, we deal with a lot of project documents, project plans, information like that provides the broad outlines of the work that we're going to do. And I find that can be really valuable to supply as context when I am, for example, generating, asking the AI to generate some boilerplate for me, some text for me that is, or a sample document, stuff like that. It really helps to get the right answer when you provide that context, so that all the things that you would want the model to know, who your client is, what their mission statement is, what they're concerned about, all of those things are available as information to the model. And it doesn't really change anything about the model's performance, except that there is now some information available to you. So that's what RAG is, and that's where it sort of sits in the landscape of ways that models can be built and extended. There is a lot more to know about all these things, particularly fine tuning. There's a number of different techniques for that, but this should serve as enough of an introduction for tonight. So a couple of diagrams here to give you a visual sense of how retrieval-augmented generation works. So retrieval-augmented generation requires us to convert our data into the same kind of vector representation that our model uses. So the way that we do that is we use a specialized tool called an embedding model, which is basically, if you remember that architecture diagram for large language models, there is an embedding model at either end of that architecture, and that's what it's for, is to convert our text into its numeric representation. So the embedding model that you use is one that is already trained. Okay, it already has been trained so that your information is assigned numeric values that have some semantic meaning already. Okay, so that's how the data is vectorized. And then when you are looking to retrieve that information, when you're looking to provide it as context, there is a retriever that sits between the user and the large language model. And what the retriever's job is to take the user's prompt, do a search through the knowledge, do a search through the data that has been provided as knowledge for retrieval, and it searches that data to find relevant information. And relevant information means information that is semantically close, that is close in its numeric representation. And then that data is provided as part of the context to the LLM, and then you get your response. So to the model, when it receives that whole payload, it's no different than if you had sat down and typed all that context in by hand. It's exactly the same to the model. It processes it as though it were all one big presentation. Okay, so there are some challenges. As soon as you start working with retrieval-augmented generation, you're going to identify some challenges, and they get pretty frustrating. Context windows is one of the biggest challenges. So storage is not infinite, memory is not infinite. Every large language model has a limited amount of context that it can support, okay? That varies. GPT-4 had 8,000 token context capacity. Gemini Flash is 1 million, which is very, very large. So again, if you think of a token as about half a word or part of a word, you can get a sense for how much text we're talking about. In practice, especially if you're working locally, the amount of VRAM, because it does end up being stored in video RAM, just like your model, you are limited by the available VRAM. So the VRAM that your model consumes plus the context size is the amount of video RAM that is required to perform, okay, in that scenario. If you are running on a local PC, like my laptop can run very small models, and you your model footprint in memory plus your context space, if it is larger than VRAM, what will happen is you get what's called overspill. And so some of the model plus context, some of that data ends up being stored in regular RAM, which means that it's not processed by the GPU, it's processed by the CPU instead. If you install Ollama as your LLM tool, you can actually run a command line command to see the models that are running, what percentage of it is running on GPU, what percentage of it is running on CPU. If you try any of this at home and it seems insanely slow to you, you probably are in a scenario where you don't have enough video memory for what you're trying to do. So if you have a document that exceeds the size of the context, or you have a set of data, because we of course could have multiple documents that we want to retrieve. If you have a set of data that is larger than the available context, the LLM cannot process all of it at the same time. It cannot give you a response that takes all of that information into account. So we have to do some things in order to manage that and work around that. RAG, the search part of RAG, just talking about the second bullet point here, it can be surprising how limited the model is in terms of understanding, I don't know how exactly to say this, like an indirect meaning. So what I'm trying to say is that if you want to know, and we'll demonstrate this, how much does it cost to buy a banana, and you have the price of a banana in your context, the model will tell you exactly what that is. But if what you have in your context is, a piece of information that is relevant to what you're asking, but not really the same meaning, you're going to have challenges. So I'll talk a little bit about the technique, which is really the focus of what we're doing tonight, the technique that I experimented with to try to work around that limitation and get better synthesis, better thematic responses. And so when I talked about the ways that I use RAG or want to use RAG in terms of document search, one of the things that I did when I first started this process was loaded up all my business documents into my knowledge base and tried to work with that. And really, it was the process of learning how I was going to actually be able to get useful information out of my business documents that kind of led me down this road. Okay, so Alex asked, how does the LLM respond to overloading its context window? There's a few different strategies that can be applied. So one would be to look at whatever would fit, so the tailing part of the content that would fit. So if your context window is, 8,000 tokens and your content is 10,000, you would lose the first 2,000 tokens. Another approach is to take the beginning of the context and lose anything at the end that doesn't fit. And another way is to take the beginning and the end and lose a bit in the middle. There's different techniques that are used, but basically that's what happens. When it runs out of context, something has to get thrown away. And you don't want that. That's not going to be good. And finally, the last thing that can be a real challenge with retrieval-augmented generation, you can't just take your downloads folder and drop it into a knowledge base and expect to get anything good out of it. The messiness in ordinary documents and data is going to be a problem. If you think about, for example, and again, I loaded up a bunch of business documents, so including my proposals, all the proposals that I've written over the years. And every proposal has a title page. Every proposal has a pricing page that looks almost the same as every other proposal. Every proposal has a couple pages of legal text. All of that stuff is useless information. And it's the same for every document. So there's nothing there of value because we have this repeating pattern through every document in our knowledge base. Then that's not going to help anything in terms of retrieval, right? Because every document will be equally relevant to that particular text. So Alex, that is configurable. That's a good follow-up question. So you want to remove any kind of boilerplate content, indexes, also markup. And now I want to make a point here about markup. Markup can be good, okay? HTML or Markdown provide structure to a document, and that structure is valuable to the model when it's trying to understand it and it's trying to understand how the text relates to itself. So it's valuable to leave in the HTML that structures the document. That's good, but you want to clean up all the JavaScript, you want to clean up all the CSS, you want to remove things that are styling stuff that are not going to provide any value to you in what you want to do. So keep those things in mind. These are all really important limitations of retrieval-augmented generation. So there are some solutions for this. The main approach for solving the context problem is chunking. So by chunking, what we're doing is we're breaking a document down into pieces so that the relevant pieces of the document can be retrieved for context rather than the whole thing. 500 tokens is a commonly used chunk size, and overlapping chunks is something that is recommended. So if you have a 500 token chunk, you would want to have an overlap with the next token of about 10%, about 50 tokens. The reason that you want that is so that you're increasing your chance that the tail end or the beginning of a chunk is going to be meaningful, right? And that meaning won't be split between two chunks. If you have overlap, one or the other of those chunks will probably have the complete sentence and the complete thought. Alex, you're making some good comments there in the chat. The approach that I've landed on is a multi-tiered approach to chunking. So I start by splitting the document according to its internal structure, right? Section headings, stuff like that. And then within those pieces, break that down into the chunk size that the model wants, 500 tokens or so. And then adding metadata to chunks is valuable. It's valuable for a couple of reasons. It helps the model. To understand the relationship between chunks when it has things like a sequence number and so forth in there. But also, and really importantly, the metadata is useful for providing citations. So if you want, for example, if you are doing RAG on the owner's manual for your car, one of the things you're probably going to want to be able to do is go and check the actual page of the manual when the model gives you some information back. And so you would probably, in your metadata, you'd probably want to include the page number for every chunk, right? You would include the page number because then the model can surface that for you. You should consider your document strategy, your data cleaning strategy, how you're going to prepare your documents, understand the documents that you're working with, think about it, consider using scripts if the cleanup can be automated or for as much of the cleanup as can be automated, and then use the tried and true regular expressions, find and replace, and manual editing. Use those techniques to get you to the last mile. Okay, so let me show you what we're talking about here. I have a little document that I made, okay? And everybody can see that, I hope. This is just a price list Okay, it's a few items, the Kilgoria General Store price list, and it's got 5 items there, okay? It's a weird store. They have eggs, cherries, monkeys, bacon, and books. So we're gonna take this document and we are going to load it into, context for, in my model, okay? And we're gonna do that by, there's a couple ways that you can do this. So if you've ever worked with ChatGPT and you have ever clicked on the little plus sign, and it looks very similar to this, and uploaded a file, this is what you're doing. This is Retrieval-Augmented Generation. Except that you are supplying a file that will be loaded into context, right? So you are just telling the model, this is your context. But what we're gonna do instead is we're gonna go over into our workspace, okay? And we're going to click on knowledge here. So this is all, now we're looking at Open Web UI, folks. Once you install Open Web UI, you should be able to do much the same things. So I've got a few items in my knowledge base already, but I am going to add a new area, and we'll call this Hackforge. There we go, a demo for Hackforge. And now I've got an empty knowledge space. I'm going to add my document. Okay, upload a file, and there it is, price list, great. So that didn't take long. You see this notification, this little notification that comes down, file added successfully. It only took a second. You guys all saw how big that file was. It was tiny. But what happened there is that the embedding model vectorized my document. Okay, so that's what's happening. When you click that plus sign, add a document, and wait, that's what's happening. Is the embedding model is operating on it. So now I have a piece of knowledge that I can use. So I can go back to my model list, pick one that's going to give me some good results. Let's go with the big one. Okay, and now I can either in my model configuration tell it what knowledge base it should always use. So that's an option that we have. The other thing that I can do is I can use a pound sign to tell the Ollama user interface that I want to use the Hackforge knowledge collection. And that will accomplish the same thing as though the model had that knowledge base already attached to it. Okay, so having done that, I can now ask a question. So what should I expect to pay for a monkey at Kilgoria's? And so if you remember, that was a $75 item. Oh, and there we go. So unrelated error message. I turned on enhanced web scrape or left it on, and I should not have. But you can see that this worked. Here we go. You can expect to pay $75 for a pet monkey or $100 if you want a house-trained monkey. So that is certainly information that was not in this model's pre-training, okay? That is extracted from our document. So that's the power of this technique. It really helps you get around the hallucination problem. So let me show you. I'm thinking this is going to work. How much does a rock cost at Kilgoria's? Now that's not in our training data. So what I'm not sure about, there we go. So what happens is because we're using Retrieval-Augmented Generation, the prompt provided to the model, okay, the system prompt provided to the model, I indicated that if it does not find the information in its context, it should not answer the question, okay? Which is a huge improvement from using an LLM with no contextual data, because those guys will lie like crazy. They will just make stuff up that sounds good and looks good. So it's really valuable just for protecting yourself against hallucination. Even even when the model has good coverage for a particular body of knowledge. So one example that I like to give is SQL Server Books Online. Okay, everybody know what that is? SQL Server Books Online. It's Microsoft's online documentation for their flagship database management system. I took a PDF copy of the Books Online for SQL 2000, okay? And I use that because it's very convenient. It's very relatively small, and I don't know if people here are SQL Server users or ever look at that documentation, but it's the gold standard for technical documentation, in my opinion. Like, it just doesn't get better than SQL Books Online. So using that as context is better than talking to the model about your 2005 era database problems. It's better because there is a comprehensive knowledge base attached, rather than the knowledge that gets baked into the model through training. Okay, it's not that information is bad. Like, the information available from LLMs is fantastic, but if you want precise, accurate information, this is the way to do it. So there's a quick example of retrieval-augmented generation. Now, that document was so small I didn't need to chunk it. It's certainly going to fit into even the smallest of context windows. But if you want to go further with it, you're going to need some of those techniques. Okay, so Alex is asking a ton of great questions. This one is the context window the whole collection of files? No. In the case when you add a document to context, yes. In the case, at least in Open Web UI, when you are using the knowledge base feature, what you are doing, under the hood, there is an entire retrieval augmented generation system that is there for you. Okay, so the retriever is a silent partner here. You type into the web interface, the retriever searches the knowledge base based on your prompt, finds chunks that match, and feeds those to the LLM as context. So that's what happens when you load a large collection of files and you use retrieval augmented generation techniques to get at it. So the thing that I wanted to try was to get at more abstract data. I wanted to get at information that's thematic to a document. Okay, and so we have the technique of keyword extraction or keyword assignment. Those are two very well understood and time-honored techniques for working with unstructured data. So keyword assignment is a process by which you process a piece of text and you assign keywords from a set limited list, okay? And keyword extraction is when you extract keywords directly from the text. Okay, so what I wanted to try was kind of a hybrid approach here. I wanted to get actual pieces of text from the model, from the context. I wanted the actual text from the context in my metadata, but I also wanted to have some kind of thematic consistency here. So I built on a technique that I've used before and extracted keywords by theme, okay? So the steps to do this, they're listed on the slide. Figure out what the key topics are for the users of this particular document or set of documents. Use an LLM to extract keywords to pre-process your data before you start to use it for RAG. And then combine those keywords with the chunks and the metadata of the chunks, add them to that metadata. And then what happens is, in effect, and the reason that I went a little bit over my skis in trying to explain what's happening under the hood here is that the reason this technique is valuable and works is that what you're doing when you create that metadata and hang it on the chunk is you're creating a cloud of search targets that sit around that chunk, right? Because each of those keywords, plus the categories, plus the thematic categories, They are data now, and they are information that that can be processed by the retriever when it's searching, when it's doing a search of your vectorized data. There is now more information to help it figure out which chunks are most relevant to your query. Okay, this was my idea. This was my notion. I wanted to understand if this would work. Yep, you got a question.
Are we also using this to limit our search area? For example, if I have millions of documents, I could potentially also use it to not having to go through the entire search space and just go through the related keywords.
Yeah, so what that now that would be, that's true. But we're now talking about, I think, a little bit of a different technique, because what you're talking about, like limiting the result set, like limiting the potential results by using the keywords as a filter. I think that would be better achieved using some kind of like a relational database in the mix, which is certainly possible. You know, retrieval-augmented generation doesn't only work on documents. There is no reason you can't build queries with the LLM, query the data, and get a response that gets mixed with the LLM's text generation. That can be done. That's not a technique we're going to talk about tonight any more than that, but it can be done. So I think that's more what you'd be wanting to use there. This is more about making a match, right? Like this is about matching, not filtering. Okay. So there's a GitHub repository. You can find it on my GitHub. Sartori is my GitHub username. And the repository is called Process Briefings. And my notion here was that I wanted to see if we could take a particularly suitable document, okay, and get meaning out of it. So the Ministry of Health Deputy Minister's Briefing Book, if you've never looked at this, what it is a thick document like this that is provided to an incoming deputy minister, or I presume a new one is generated out of change of government and whatnot, that explains how the entire health bureaucracy works, okay? It's a very information dense document. It's very well structured. It has all the things that you would want. You know, it has a table of contents. It has well thought out section headings and so forth, and it's authoritative. So there's no better resource out there to understand the Ministry of Health in a compact and concise form than this briefing book. So I wanted to take that document and I wanted to get thematic metadata that would allow me to query it a little bit more abstractly than to just be able to ask a question. Who is the current CEO of Health Canada? Would be a RAG question. But if I want to know, well, what is Canada doing about narcotics? What is Health Canada's role in narcotics reduction, right? Consumption reduction, whatever. That's the kind of thing where you're going to get spotty responses if you haven't pre-processed your document. But if you include keyword extraction and then you categorize those keywords so that the model, when processing that data, can understand the theme, the thematic element, and how those keywords relate. In some ways, if you want to think about it, you're making its task easier. You're reducing the amount of work that has to be done at your prompt time by doing some pre-processing. So this is what I tried to do, and that is the key method there in process briefings that you see on the slide there. And essentially what we're doing is, first we are splitting the document at headings, okay? And then we break it down into its chunks at the 500 character size, okay? And then we call the method to generate and attach the metadata to every chunk. In a nutshell, that's what we're doing. And now you're going to get to see. Okay. So I know this is tough to see if you're in the room. Sorry, folks. Let me zoom in a little bit on that if I can there. That makes it a little nicer. Okay. Not going to worry too much about that. So when you copy this repository, you're going to see there's a few files here. Okay, the configuration file. The configuration file is pretty simple. It just has a couple pieces of information. What model do we want to talk to, and what's the URL at which we communicate with that model? Okay. There's a blog post, which is the blog post for my data podcast that went along with this document. There is the source document itself, the cleaned up deputy minister's briefing. And if you want to play with this, and I really encourage, oh, thank you, Alex. I really encourage folks to play with this. One really good way to see the benefit of the techniques that we're looking at here is take this raw document and load it up into an LLM, into its knowledge base, and try to query it, try to get answers out of it, and then use one of the processed ones. There's a Docker file here so that if you are running Docker, you can get this all set up without having to do any Python installation or configuration. And then there's one pretty small Python script that does all the work. So I just want to call out one small piece here. So that's the code that actually calls the LLM. There's our text chunking. Okay, I wanted to show you the queries that, how do I make that go away? There we go. I wanted to show you the prompts that we use. So they're all pretty much the same, but there's our 6 prompts, okay, for keyword extraction. Okay, and you can see that they are all similar, except that they are asking different questions, right? They are asking different questions, and so we get a different response from the model for the same chunk of text for each of those questions, okay? Really, it's not a very big script or a very complicated script. I recommend that you take a look at it and give it a try yourself, because there's not a whole lot here. But also in the repository are 3 files. These are the processed files. Why are there 3? Because I wanted to provide a comparison between the performance of different models. So we've got 3 different versions of the worked, prepared data that were produced by 3 different models. 2 versions of Qwen 2.5, which is an open source model out of China. It's made by Alibaba. The Qwen 2.5 series is I think, widely felt to be one of the best and most performant open source models out there. They do have a fine tune that is specific to coding, to being a coding support model, and they're very good. And they come in many sizes. So no matter what kind of hardware you have, what kind of VRAM you have available, there is very likely a Qwen that will fit. They go all the way down to 500 million parameters, which is exceedingly small. You could probably run that on a phone. So that's the Qwens. And then Llama 3.3 is Meta's flagship model. That's the latest version of their flagship model. And so then the after the dash in the model name there is the size. So without getting too deep into a completely other topic, I just want to say that the number represents the billions of parameters that model has. So we have a 14 billion parameter version of Qwen 2.5 and a 72 billion parameter version of Qwen 2.5 and a 70 billion parameter version of Llama 3.3.
How many bytes?
I couldn't tell you. So generally speaking, when we're running locally, we're using a quantization. So the model's size in RAM is going to be roughly double the size of parameters in gigabytes. So if it's a 14 billion parameter model, at its full size, it would require 28 gigs of RAM, of VRAM, okay? But there's a technique called quantization where those vectors are converted into lower precision numbers. And the 4-bit quantizations are pretty widely understood to be a sweet spot in terms of it cuts the size of the model down significantly. Now they're, you know, like I think Qwen 14 is something like 7 gigabytes that it requires. So 7 or 8. So it cuts the size in RAM down significantly, and it does not significantly degrade performance. Performance is degraded, but it's not significantly degraded. So you can get pretty similar performance out of a quantized model as out of a full-sized one. So I went to my API provider, Nebius, and I tried the 70 billion Llama 3.3 and the 72 billion Qwen 2.5, and then I locally tried the 14 billion parameter Qwen. All of them improved performance. They all improve performance. But the Qwen 2.5 72 billion version is so much better than the others. And I want to be fair to Llama. I wrote those prompts, I refined those prompts, I tested those prompts against Qwen 2.5 14. When I went to the larger version of Qwen 2.5, I got just nothing but a performance improvement, nothing but better output. When I went to the larger Llama, I got worse performance. The output that I got was worse. But I don't believe that's because Llama 3.3 is that much worse than Qwen 2.5, and benchmarks don't bear that out. What I think happened is I did not spend any time at all refining or testing my prompts or trying to improve performance from my prompts to the Llama model, and they're really sensitive to that. So I don't know that Llama is worse. I know that in my testing it didn't work as well. Big distinction, I wanted to make that point. But looking at this data, so you can see what the structure looks like, and now here's a, here, let me put on word wrap, makes things a little nicer. So here's the a chunk of text. Well, let's find one. Okay. Let's just go to the beginning of this one, whatever it is. So here's the chunk's text. Okay. It looks like it's some stuff about the priorities of the priorities of the health ministry. Okay, really important. So there you go. There is a ton of keywords extracted and phrases extracted from that chunk because they all relate in some way to the priorities of the health ministry, either because they're called out as priorities. So you saw that the text indicated those are priorities and therefore they're listed, but also the model is able to determine from the text itself whether or not something may or may not be a priority or be represented as a policy or a priority just based on its structure. Okay, so oops, I moved around too much. So where is it? There we go. So the policy and priority keyword, very filled out for a chunk of text that is all about policies and priorities, right? It says nothing about organizational structure. So the organizational structure section is empty, okay? So when we're talking now, when we're talking to the model, we're asking it questions, it has this additional information available to it to better understand a particular chunk of text. Okay, just to give you a flavor here. Who are the key partners in this work? Okay, what relates to history and legislation? Okay, so you get a sense of how this works. Okay, yes, Alex, you would have to rechunk. The question was, how does chunking work on changing data? So if your data is changing frequently, you probably don't want to use a static representation. You probably want to use some kind of data-driven representation. That's what I would suggest for your data. And you'd want to think about how you could, like, you'd want to think about extracting that data for context in a different way, is what I think if your data has frequent changes. So, yeah, so that's what the document then looks like, and hopefully we have just a little bit of time left, but hopefully we have enough time that I can, yep, there we go, I talked about that. And there's a few things that we can do in the future. I mentioned the prompting. This particular technique has nothing to say about multiple documents or the relationship between documents. It was an experiment with one single document. So there is room for improvement there. And I'm completely relying on OpenWebUI's RAG pipeline here, which got me started. I really wanted to explore this technique. I really wanted to see if I could get better performance out of it. But I haven't gone to the extent of designing and building my own pipeline yet. So that's future work. That's all work that's possible. It's also all work that I think if anybody who's here or watching online, if you want to take a crack at extending this and maybe learning something new, these are all, I think, really, really good opportunities for extension of this project. So let's take a look here at the performance of the model with, okay, let's see, where's my models? Here we go. And we have Health Canada Helper. Okay, so Health Canada Helper is preloaded with our knowledge. And so now, just give me 1 second. Okay, I don't have a sample question, so I am just going to make one up. All right, so we've got the DM briefings are loaded. Let's see. So one of the things that's really nice about the Quen 72 billion parameter version of this metadata is that it's pretty responsive to even kind of obtuse queries, right? And this is one of the key differences in performance. Like, I didn't talk a lot about what the difference in performance was. One of the key differences in performance of the different files, from the smaller file to the larger one particularly, is that you get more accurate responses, but you also are able to be a lot sketchier in your questioning. You don't have to like hit the middle of the target in terms of a question. So I could do something like, what's the deal with Health Canada and illegal drugs? I can just ask a question like that, and let's see what kind of answer we get from our knowledge base. So what we're seeing here, and I know I'm pointing at the screen for the folks who are online, I'm pointing at the that little message that was indicated that it was searching. So the model is not engaged when that's happening, right? That's your RAG system that is doing the searching. So here we go. And what we're getting back here is very good information. And it's sourced, okay? So we've got our sources. Let's see. Okay. Now we've got something we can tell me more about the CDSA. Okay. The Controlled Drugs and Substance Act. Okay, that sounds like really valuable information. And then, of course, what you would do here if you're experimenting is you would take this response and you would go back to your context and you would validate it against your context. And make sure that the information that you're getting here is quite accurate. But I actually have a doubt. So let's go over to the models here and take a look. So there you can see the system prompt. Oh yeah, we got our Health Canada data. Okay, so one last thing I'll show before I go away, and we're over time and I'm late for a meeting, but I really want to show you this. So this is the system prompt. Many models, not all, but many LLMs support a system prompt, which is provided in addition to the user prompt. So the system prompt is, for example, when you open up ChatGPT, it has a huge system prompt that gives it a long list of do's and don'ts and suggestions and tells it how to respond to your query and tells it that it should use Markdown when it's answering and all kinds of stuff like that, right? So this system prompt, and we'll zoom in a little bit here. There. This system prompt is for retrieval-augmented generation. So it is very specifically providing instructions about what to do with the context, what kind of information it should give or it should find in the context, and then some response guidelines so that you can see how important it is to be very specific about what you want done. And this is a system prompt that took quite a bit of time for me to refine and produce. It works quite well. It's for this specific data set. Okay. The RAG system in Open Web UI has its own prompts, and it even has its own retrieval prompt. So you are able to get good performance without doing this. However, creating a system prompt that is customized for your data set and your use case, that's what's going to give you the best outcome. So that's as much information as I can give you in an hour about retrieval-augmented generation and the technique that I used. Again, that code is up on GitHub. And if you do use it, or you do, especially if you extend it or try something new with it, I really would like to hear about it. Come back and talk to us. The other thing I want to mention is that there is a Hackforge talk later this month. The Linux users group is doing a Hackforge talk on setting up a local computer for running LLMs, and Randy Topliff will be taking you through in great detail all the things that you need to know and do in order to set up LLMs on your own machine. Randy's very thorough, he's very smart, and he's technically excellent, so you'll get a much better presentation than you got today. I highly recommend that you do that. And with that, we're going to stop the recording, and I want to thank everybody for attending and your interest. It's very appreciated.